So today we're going to talk about an exciting new set of features that we've added to Lens, really focusing on that problem of scale. I'm going to be joined by Eve Boyce Ratliff, who's on our team and leads partnerships with Lens. And I think it's going to be really fun today. This is going to be a big year for the stuff we're building with Lens. You're going to see a lot of new features that we're bringing. And this first one, I'm really excited about because we've been talking about it for a while. So, just to start for our agenda, we're going to keep it simple. I'll give a little bit of a background on the company and the origin story of Lens. And then Eve and I will walk through the product and then end with questions and answers. And it should be quick and fun. If you can see it, maybe over here or maybe over here, there should be a Q&A feature where you can ask questions, and you could just do that as we're talking, and then we'll have them all queued up for when we get to that section. So what is Lens? Well, I'll start by just giving a quick background on myself. My name is Marshall Moutinot. I'm the CEO and co-founder of Upstream Tech. My background is in computer science and startups. I worked in the more traditional tech sector before starting Upstream almost 9 years ago, which is wild to think about because that is the large majority of my career. And we started, Alden, who's my co-founder, and I, we started Upstream because we really wanted to align the skills we had gained working in that traditional tech space with the impact that we wanted to see with our work. So we started by building all sorts of experimental demonstrations, I guess you could call it. We had machine learning models that would detect things from different satellite images. We built applications around specific environmental decision processes. And what we found as we demonstrated that to our earliest partners was that there was a more core problem, which was that they were in the process of scaling the work they were doing, more project locations or vaster tracts of land. They were scaling, and their monitoring practices weren't keeping up with that scale. So we had all this fancy technology, but there was that core problem that was present. And actually working really closely with the Nature Conservancy in California helped us realize that there was an opportunity for us to build a product to tackle just these, just those challenges. So that's where Lens came from. It took a step back from these super high-tech demos of machine learning for this and that, and reapproach the problem of, okay, how can we enable monitoring that scales? How do we use technology to do that? And how do we empower organizations that are doing really exciting, great work? So I imagine many of you who are joining the call are Lens users, and some of you, maybe it's a little bit newer. You haven't had a lot of time in the platform. But our goal is just that. It's trying to connect data and an application and workflow with users who may not always have the deep technical expertise in those areas, to make it as easy as possible. And I think one thing that's really exciting, just looking back, is that I think we've achieved the original goal of trying to help scale monitoring. But the but there is that our users keep really pushing scale. And what we've realized is, from that poll we just ran, there are folks monitoring 50 properties, 100 plus properties around the world. And at that scale, it becomes hard, even with a tool like Lens, to get through every property at a cadence that you may want to get through them in. So that is the kind of problem statement that this new feature was born from. Our customers were coming to us saying, okay, Lens is awesome, but I have 1,000, I have 2,000, I have a property that's 100,000 acres, right? Like, how can I, get through all of the imagery, get through the monitoring process? And so that's been the problem statement that we've been focusing on. So with that, I want to invite Eve onto the virtual stage. I don't know how to do that. There you are. Hi, Eve. So cool. I think it's going to be really fun to walk through this feature. I've tried to lay the stage for the problem statement, but are there any specific conversations you had with customers that solidified in your mind that this was something we needed to build?
Yeah. And hi, everyone. Nice to see you. Thanks so much for joining us. And yeah, I think, Marshall, you set us up really nicely outlining the problem. So yeah, we've heard from a bunch of customers who have use cases that sort of align with that challenge of we're scaling, we have a bunch of sites, we need to be even more efficient than that process of manual monitoring each individual site every year, or even more often than that. Some of our customers are really interested in aggregating impact metrics. And so for them, they were asking for features around that. How do I understand the impact of the work that I'm doing across a portfolio versus having to focus on those individual sites? Some of our customers are interested in comparison. So they have, 1,000 small sites or plots where they're trying to understand, which are my most productive sites, where are the areas that we're seeing risk, and how do I do that in an efficient way where, again, I'm not clicking into each one of those 1,000 little plots. So I think both of those sort of aggregating impact and comparing a bunch of sites came together really nicely in this feature that we built, which you'll see does both of those things.
Yeah, absolutely. We're going to talk a little bit, Eve will walk us through the product. But maybe just one thing that I want to call out early on is there's, with a lot of these software products are aimed around supporting efficiency or decisions, especially in the environmental space. There's this tension between building something that works for everyone and building something that's completely bespoke for one customer. And as a computer scientist originally, I've followed this movement around malleable software. And I think I'm mentioning this because I'm really proud of the team and how they built this in a way that is malleable to a customer's specific needs and the specific objectives that they're trying to understand in aggregate, while also being really efficient to deploy for our customers. So as Eve walks through the product, we're going to show lots of different examples that are going to speak to specific customer use cases. But the idea is that the product is malleable and in a way that's really exciting to me for us to fit it to specific needs. So I think we could jump into the demo. I think I'll just quickly say that for all the people who submitted Q&A stuff already, thank you. Everyone gets 10 points for complimenting my daughter's drawings. So I always welcome those Q&A questions. All right, Eve, you want to share your screen?
Yes. Okay. So this is Lens. It's a web-based application. And I apologize for those of you on the call who are Lens users. We're going to do a little overview of what Lens is to start, because I think without the context of the original features of Lens, all of these new features don't make as much sense. So hopefully, even if you're a Lens user, you find something interesting in this, but we'll try to move through this relatively quickly to get to the new exciting stuff. But Lens is a web-based application. It is web-based strategically. Part of the value add that we provide to our customers is that we're handling all of the data access and data processing on our end. And if you've ever worked with these types of geospatial files or remotely sensed data before, you know that they can be really big, really cumbersome, take up a lot of space, take a long time to load. And a lot of what our team spends their time on is figuring out how do we stream this through a web-based platform in a way that's really quick so that those efficiency gains really are realized. So that's sort of the first thing to know about lens. The next thing to keep in mind is that it's area of interest based. So you're adding properties. Those can be as small as an acre. They can be as big as hundreds of thousands of acres, but it is sort of this discrete area that you're identifying that you want to monitor. And you can do that in a bunch of different ways. So you can upload from a geospatial file. You can do that one by one with your sites, but you can also upload one file with your whole portfolio of sites and it will automatically load in. Or if you don't have that, you can just draw an area on the map. So we try to make this super accessible and easy, not only for people who maybe just don't have the shapefiles because they don't have that technical expertise, but also because we want this to be something that's really a living tool on your desktop where maybe a landowner reaches out to you and sends them your address and you're like, oh, let me see what I can find out about this property. I'm going to load this in right now. And it doesn't have to be a big lift to do that. Today, we're going to be looking at an area of commercial forest land in California. And we can see this boundary is the area that we loaded into Lens. And right now we're looking at what we call a true color image, which is basically a straight up satellite image taken by a camera in a satellite. This image is one that I ordered from our order pane over here. So one of the things that we've done is build relationships with all of the major commercial satellite providers. So that's companies like Airbus and Maxar and Planet. And we have done the negotiating to acquire access to their archive of imagery. So they capture images all the time. They go into their library of images that they've captured. And one of the things that we've heard from our partners is it can be difficult to access that data. There's often pretty high minimums that you have to meet, or you have to order an entire tile of imagery. And so we basically take on the work of negotiating with those data vendors. All of the images that have been captured of this site pop up in here. And then you can just pick and choose what you want to order. So I can preview this image. This is from just a couple days ago. And if it looks good, I can click order and it will pop up into my account. So I went ahead and did that for an image that was just captured earlier this month. And that's what we're looking at now. This is a 30 centimeter resolution image. So if I scroll in here, we can see in this cleared area, you can see areas where timber has been left in this clearing. We can see roadways pretty clearly, areas where vegetation has been left standing. So this 30 centimeter data is really high resolution, high quality data. And oftentimes what our customers are looking for is some kind of change. That's often the type of monitoring that they're doing, is some kind of change assessment. So in this case, I want to understand what's been happening on this site. What's the latest over here? So I'm going to turn on our compare mode and I'm going to compare two images. The one on the left is from 2023 and the one on the right is from 2025. And really quickly, as I scroll back and through here, my eye just immediately goes to this area down here where we can see that a timber harvest has occurred between those dates. Sometime between 2023 and 2025, those two areas were harvested. And so that's what we're going to focus on today, is figuring out some more information about what happened here and when, so that that can inform our monitoring. So I can see that this area was harvested. The next thing I'm going to do is I'm going to make a note about it. So one of the things to know about Lens is it's meant to be collaborative. So it's almost like a Google Doc, where if I'm doing work in Lens and my colleagues are in the same account, they can see the work that I'm doing. And you can see here, I've made some notes. My colleague Katie has made some notes. Notes are basically like annotations to the imagery. So they can be tied to a specific place on this property, or they can be tied to the overall property. They can include graphs like these. We'll talk about what these are in a second, but lots of flexibility in terms of what these notes look like. But it's a really great way to basically save, hey, you know, something's going on over here. I want to remember that something's happening, or I want my colleagues to check out what's going on. So I'm going to make a note about this new clearing. I'm going to actually draw a little polygon around this. That way I have the exact boundary of this area. Looks like it's about 7 acres. That just popped up. So I'm going to say 7-acre, clearing. And what this note is going to do is it's actually going to append the two images I was looking at when I made the note. So you can see it has that 2023 and 2025 image. Now, when my colleagues go in, they'll be able to see the exact same imagery that I was looking at when I made this note. It also saves the GPS points and the acreage. So I'm going to go ahead and create that note, and it's creating it down the bottom over here. And now what I want to do is dig in a little bit more on what exactly happened on this site and when. And so this is where our analysis features become really helpful. So I'm going to go ahead and open analysis for this polygon that I drew when I created the note. And that's opening up this pane over here that says analysis. And from the analysis pane, we can choose from a broad number of different types of data sets to run our analysis features on. So you can see there's biodiversity data in here, things about burning, some of our partner data is around forest cover, carbon. We'll talk a bit more about those, land cover data. So a lot of different options in here. In this case, because this is forest land, I'm going to use NDVI, which is the normalized difference vegetation index. So that's a measure of photosynthetic activity happening on the ground. And in this case, we're deriving that off of Sentinel-2, which is a satellite that captures data every 5 days. And so that's really helpful for understanding change over time at a sort of relatively frequent clip, which can help us figure out more detail on what's going on here. And in this case, because we know this happens sometimes in the last 2 years, I'm just going to look at the last 2 years of value here. And so what this just did is it plotted out the average NDVI value for each of those Sentinel-2 sensing. So if I hover over any of these points, we can see the date of the sensing. So that's when the satellite captured this image. And then that 0.91 is the NDVI value for all of the pixels, the average value for all of the pixels within that polygon that I drew. If I actually click on this, you can see what this data looks like as it loads. So right now we can see this is heavily forested. This is before this harvest happened. This is dark green. That's an indicator that there's a lot of vegetation here. As I start to explore this chart, I can kind of look around to see, are there any aberrations here that would indicate that there's a harvest? And the only aberration that I really see is actually right at the end of this chart. So if I zoom in here, it actually looks like this harvest just happened. So the last 2 sensings are the sensings where I'm seeing that drop in NDVI that would indicate that a harvest has occurred. We start to see that in May. If I click on this May image, I can look and actually see it looks like they had harvested part of this polygon that I drew in May. But then by the time we get to June, we can see this full polygon area that I had identified is fully cleared. So we now have a lot more information about what's been going on this site. We now know that this is actually a really recent change. This just happened within the last couple days. And it looks like this harvest is maybe done occurring, but we can actually go back to the true color imagery. And now that I know this, I can zoom around for a little bit more context. We can actually see, looks like there's not a ton of equipment left on the site. Maybe this is a piece of equipment. So they may be continuing harvest in this area, but I would guess that this stand is starting to be completed. I don't see other equipment on here. So we just learned a lot about what's going on this site in about 3 minutes, which really I think is the power of Lens, sort of as is that you can flip between all of these different data sets. They all load super quickly. You can run this pretty advanced analysis with just a couple clicks, and you can really understand what's going on a site at any given moment.
And there are other like pieces that we won't have time to get into that like even supercharge this further, like our lookout feature that does sort of the change detection for you. But Eve, I have thousands of properties, and what you just showed me, like how could I possibly do that for each of them? That's kind of the question that's been posed to you in the past, right?
Yes, exactly. So we just went through what we would call sort of the traditional monitoring workflow of you have one site, you want to understand the details of that, you go in and you click around. And as Marshall mentioned, we do have some automatic change detection features. You can see those in this lookout pane over here. Here's an example of one of those that popped up on this site previously. So there are tools to make this easier, but traditionally our customers have been doing this on a property by property basis. And so that's where we're super excited about our dashboard. So this is the new feature that just launched. And basically what the dashboard is doing is a lot of those same types of analysis around time series, a lot of the same data sets that you see in that analysis feature, but rolling them up to the multi-property level. So we're doing this across multiple sites within your portfolio and giving you an aggregated sense of what's going on. And so for the purposes of this, I'm going to pretend to be a couple people, and we can talk through some examples of how we anticipate that our customers are going to use this. So my first persona is going to be, I work for a land trust. I work hard all year long to conserve a lot of land. This last year, I had a banner year. I conserved a ton of land. And it's March now. My comms team has come to me and said, you know, we want to report about your impact in the annual report. And one of the metrics we want to talk about is the amount of carbon sequestered in the land that you have conserved. This is like sort of a real example because I used to work in the conservation space doing conservation acquisition work, and I've gone through this process before. And the process that we used to use is sort of site by site, getting a sense of the acreage, how much of that acre is forested, using kind of a back of the envelope estimate of, how much carbon would we expect to be in an acre of forest, calculate that all up, add it up. Pretty rough estimate, and also pretty time consuming to do that work. With these charts, we can aggregate data around carbon in partnership with some of our carbon data providers. So we work with Chloris and Planet. They're providing biomass and carbon data, and we can basically roll that data up to the portfolio level and give you a total number of carbon across all of the properties that you've conserved pretty much instantly. So in this case, I'm now this persona. I've logged into my dashboard. I go over to this most recent number. I can see that across all of the sites that I had conserved in 2023, 4.1 million tons of carbon was sequestered. I can actually open this up and I can see how the individual sites are contributing to that. So if I want to understand in 2023, which of my sites contributed the most in terms of total carbon sequestered, I can look at that. I can see which is most least productive. And then I can also understand, how have those sites changed over time? So what was once kind of a pain of a process to do is now extremely easy with this dashboard and should take mere minutes. Your comms team could just do this directly without even emailing you. So that's one of the use cases that we've heard from a lot of our partners that they're excited about, and I think sort of knocked it out of the park in terms of enabling that use case here.
And just to underscore one thing about that, we're focused on building the best application for this process that can exist. And that's why we partner with others who are focused on building the best possible data layer, whether it's carbon or something else. So I think that really allows, back to that kind of malleable software piece, it allows us to work with you and the data set that you prefer once you weigh the options to create the chart that meets your needs. But the key is that what the dashboard allows you to do is take a signal that is a signal per area of interest, per site, and then aggregate them up to give you some high-level insight without having to dive into each of those sites and aggregate it manually.
Yeah, totally. Okay, I'm taking on a new persona. My persona now is I work for an agricultural best management practice funder. And so we're funding farmers to implement cover cropping practices. And now we've paid them and we have to make sure that they have actually done the cover cropping. So in this case, we're using NDVI data, which is that vegetation vigor data we were looking at earlier, that sort of green map. And that's super helpful because on agricultural fields, during peak green up, we'll see a lot higher NDVI values. And when the field is fallow or not growing, they'll be lower. So what we've done in this case is we've loaded some control fields into Lens and then some areas that we know, or at least we hope, have implemented cover cropping practices. So we can first look at these control fields. I'm going to turn on all 3 of them on this chart. And we can see they all follow pretty much the same sort of pattern in terms of NDVI over the course of the year. So we can see in the summer of 2023, we see this peak while things are growing. Then it goes down in the winter, and then the next summer we see that peak again as things are growing. I'll keep one of these on, but I'm now going to turn on a cover cropped field. And so we can see this sort of cover crop field too. This is one of the farmers we've been funding, and we are looking to confirm whether they have actually implemented cover cropping practices. So if we look at the same graph, we can see sort of same peak green up in the summer and then same fall down in the winter. Looks like they did not implement cover cropping in 2023. That's fine. Our program ran in 2024. And so we now see another peak. This is sort of the growing season in 2025. And then we see a third peak that's in the fall of 2024. And so that's a signal to us that there was a cover cropping practice. They implemented fall cover cropping, and we're seeing that peak there. We can do this with lots of different fields to understand, who has been actually implementing the practices. In this case, we actually see a bunch of peaks. So it looks like there's probably spring and fall cover cropping happening here. So a super easy way to do those checks in a way that was once pretty manual. I mean, the sort of pre-tech version of this was probably driving out in a truck to view fields, and we've heard of people who are doing that. But even before the dashboard, a lot of this would be sort of running that on an individual scale as opposed to how efficient and easy it is here. Marshall, I don't know if you want to add anything about this persona or use case.
I'm actually surprised you didn't ask me to like act the different personas. I would have done a costume change in between them. I'm super excited about this one in particular, just because early in Upstream's journey, we did focus on a number of agricultural programs that were paying for performance or incentivizing these kinds of changes. And it was like detecting the change was the challenge. And I think it's pretty exciting to see how you're able to do that at scale so efficiently. So yeah, I'm pretty excited to see this one in particular, and I think it just speaks to the creativity of this piece of Lens, which is that someone on our team said, "Hey, wait, couldn't this help with this?" And we were able to create an example that really clearly demonstrated how it could be applied to that specific problem, even though that's not. We do have some customers that use it for that kind of monitoring, but that's not our core case. But it was very easy to adapt Lens to be able to monitor that.
Yeah, I'm super excited. We just rolled this out a couple of weeks ago, so our customers are just starting to use this feature, but I imagine we're going to learn a lot from our customers because this is so custom configurable. I think a lot of our customers will probably come up with ways that they can use this that we haven't even thought about yet, and that's super exciting. Okay, I'm going to do one more persona, and then we will get to questions and answers. Now I am a conservation group doing smallholder afforestation projects in Kenya, and I'm interested in answering a couple questions. Part of my project is preventing deforestation, and then the other part is planting trees. So first, I want to make sure that for all of my little plots, and this is a project that has 170 little tiny plots. So this is a great example where that sort of traditional mode of monitoring can be really challenging and expensive. So 169 little sites, and I want to make sure that there's not active deforestation happening across them. The project started at the end of 2017, so these peaks are okay. Part of the project is sort of preventing future peaks. And we can see here, right now we're using the global forest loss data. And so this can be a helpful way of looking at sort of total acreage and percent of a property that's been seen deforestation over time. And so we can now look sort of since 2018, we are seeing that downward trend of deforestation, which is awesome. I can look at that overall, but I can also go into each year and super easily filter to understand which of these sites have contributed to that total number. And I think that's super helpful here to understand. Instead of having to monitor all 170 of these sites, I can now really quickly prioritize the monitoring of 8 of these, where we're seeing a signal that potentially deforestation has occurred, dig into those with the higher resolution data that's available in Lens, start to do some of that process that we worked on earlier together, looking at things like Sentinel NDVI and other resources. But the ones that are zeroed out, maybe I decide that my methodology is basically that I trust this data enough that that is confirmation for me that I feel good about this and don't have to do any additional checks. So this can be super helpful for sort of zoning in, honing in on the areas that are most important for monitoring. The same project, we're also interested in seeing how trees that have been planted on this site are growing over time. And this one's interesting because there are some limitations to using data like the planet carbon data. One of those limitations is that for tree planting projects, it can take a while before they're tall enough to generate a spectral signature that actually gets picked up on in the data. So we know that most of these trees were planted in 2018. We're actually just starting to see some increases in the carbon in 2022, and they don't really take off until 2024. And this, I think, is where Lens can play a really helpful role for providing that additional check on top of data like this. So if we filter now to see which of these sites are not contributing to carbon at all in 2022, I can actually click over to one of these sites and do a little bit more of that investigation myself. So in this case, I already ordered some high resolution imagery, and I can zoom in. This gives you a sense of how small these little areas are that are being planted. but I can zoom in and see some signal of the fact that trees have in fact been planted. So while we're not seeing that signal in the carbon data yet, I do feel like this project is on track for doing the things that it was supposed to do. And so that can be a helpful sort of counter check to confirming what we're seeing in the data, and helpful with, communicating with people on the ground, project developers, whatever it may be, that would be the follow-up there. And then I will just end with a note about dynamic baselining, which we hear from our partners in the carbon space a bunch. Dynamic baselining is basically the concept of taking a project area and then comparing it to a bunch of controls that are outside of the project area. And the reason that people in the carbon space are interested in this is you basically want to control for natural regeneration that might occur on a project without any kind of intervention, so that you're not getting credit for trees that are going to grow up naturally, but only getting credit for the work that you're actually doing on the site. And doing a dynamic baselining sort of control process has always been something that does require technical expertise and can be challenging. What we've done is we've created two different charts in our dashboard. One is a bunch of project plots, and one is a bunch of control plots. And in this case, we're using the Planet Carbon 3 meter data for both of these. And we can really see the difference right here. So this is sort of like a dummy site that we set up. I mean, I think a carbon project developer would dream to see this kind of clarity in terms of the difference between the project and the control, but really helps indicate or show you how easy it is to set something like this up. They could be on the same chart, they could be separate, but I think take something that once feels quite technically challenging for folks who are working in this space and makes it pretty much just a couple clicks on the button to understand, which of these sites are contributing, like both with the project plots and then also the controls. Okay, Marshall, I will turn it over to you for any last sort of closing thoughts before we start answering questions.
No, well, I mean, even just as you're talking, I'm being reminded of conversations we've had over the years where this would have just straight up solved the problem.
Yeah.
Like, there are a lot of performance-based programs that were being proposed around shoreline and erosion control and all sorts of discussion around, okay, how do we monitor the factual versus the counterfactual locations to show and it's just this, it would have been so easy with this. So, yeah, I mean, I'm authentically, like, my mind is churning, even though I run this company and think about this product all the time. So yeah, that was great. And thanks for walking us through, Eve. And thank you for everyone who's been asking questions. We have a pretty good queue. I think the one last piece that I want to highlight, back to the theme of how malleable this is also that we really try to act as partners. And I mean that not just in the kind of empty way, but we really try to help select which data is suitable for which kind of decision and monitoring. And that's actually why it's so helpful that we aren't ourselves producing all of these different layers. We have really sophisticated team members that do machine learning, and we've even created some of these layers in the past. But I think it's actually helpful for that separation of concern. So we could be a partner sitting on the same side of the table as you, looking at all of the different options spread on the table and trying to pick, okay, these are the shortcomings of this, but I think we can use this because of this. Or, here are the caveats, but I think this can really help us achieve most of what you're trying to do here. So that's really, that's something that I think is wonderful about how the team works. And I think it really sets us up perfectly for the kind of creativity that's going to go into creating dashboards for our customers. So maybe we can take this as an opportunity to switch over to some of the Q&A. Let's see. First one is a layup. I know we already responded in text, but can we get access to the recording? Yes. Thank you for helping me warm up on the Q&A. Can you see the imagery before you purchase it? So this is kind of one of the core lens functions, like Eve showed, of ordering true color imagery. It's called the archive, but it does update as images are taken. You're able to see a preview, which gives you a sense of, is the quality decent? Is there clouds covering the area that I care about? And you can use that preview as a way to gauge if the image is going to be helpful for you. Let's see. Charles asked a number of great questions around the carbon data, and I think that really is core to how we are trying to be a partner, and we have a lot of documentation around the layers. I think, Charles, your point is good. I don't think the chart was labeled specifically with above ground, and maybe that would help clarify that if we're showing to external audiences, for sure. But I pasted in response to Charles's question, which is your data above ground carbon solely or below ground too? So I pasted a response to the documentation that goes in depth on the methodology and what that specific vendor's data represents. Let's see, we got a bunch of other ones. I'm going to start adding them over. Eve, do you want to take this one? What change detection tools are available for small areas?
Yeah. So we talked a little bit about lookouts. We didn't get into it in depth, but lookouts is our built-in change detection feature. So I showed you an example of a lookout. It's based around policies. So you can basically create your own change detection policy within Lens that allows you to get notified about things that you care about. And that resolution of the change detection policy depends on the resolution of the data that you're using to build it. So as you look at these, you'll see on some of them in parentheses, there's the resolution here. Some of these are 10 meters, some of these are 30 meters. Depending on which data you choose to use, that will determine how small the area in question needs to be that generates an alert. The other component of this is, for example, if I want to be notified about, let's say I want to be notified about algae blooms. I'm doing water quality monitoring. I can set a threshold to say, I want to be notified if there is an algae bloom area, an area within my water body that hits a threshold of 0.1 or above. And then I can also set what percentage of the property area I want to see that change before I get notified. So that's another piece of the sort of customization of this that dictates how big the area needs to be in order to generate an alert. We are sort of exploring and thinking about now whether there are ways to also build change detection on some of the true color imagery that we have available in Lens. Most of this right now is based on data layers that have some sort of numerical value associated with them. So we're looking at a change in that sort of index value that generates the alert. I don't know how ready Marshall is to share much about that, but I will say that's something that's on our minds, on the horizon. And
spoiler alert. Yeah, I could share a little bit about it, but I think being academically, I was a machine learning person before we called it AI. So that kind of stuff is my passion. But I think we actually made the trade-off very consciously that by simplifying it and actually giving our users control over exactly how that notification was triggered, even though it's a simpler method of detecting change, it actually resonated more with our users. It gave them more control. Again, back to the theme of malleable software, something that I was really excited about to see how, if you look at our customers' accounts, they have all these policies that they're making that are specific to them and their use case. It's really cool. So I'll talk a little bit about the other stuff at the end. So thank you, Eve, for that one. Is there any data available of India, which is more high resolution than Google Maps? Yes. So the archive, the true color, which is what you'd see if you're in the sky looking down, that archive is global. Most of our data is global. So I would say there's actually more of a difference in availability of that imagery, the true color high-res imagery from our vendors, based on like rural versus urban. If I pulled up any urban environment around the world, as long as it's not a war zone or something that a sanctioned state, there's going to be a ton of imagery. If you're in the middle of absolute nowhere, even in the US, where some of these companies are headquartered, you may not have a ton of imagery, maybe just a handful of captures every year. So I think it's really case by case on data availability. And in terms of Google Maps, they have pretty good, they're contracted with some of the same vendors. I think the big difference is they're trying to collect one capture across to kind of aggregate into this base map. And this gives you control to select exactly what scenes you want, maybe a couple months apart to look at the change. And so it just gives you a lot more control, and you could see the exact date of capture and all of the details there. Charles asked another really great question, which doesn't have a simple answer around, well, I'll just read it. How are the control plots selected for dynamic baseline? I don't know much about this, but there needs to be some solid method to select those. Absolutely. And I think this is, again, where collaborating with our customers is essential. There may be some simpler answers. I think the cover crop piece is a simpler answer where you may have specific controls enrolled in a program and you know the locations of those controls. In a forestry case, it may not be so simple, and it may require a little bit more creativity. The cool thing is we have scientists on the team who have background in this. They have backgrounds in GIS, or they have a degree in forestry. And so we may not have all the answers, and we may need to work with you to establish what those control plots should be. But I think we have the background to be helpful in outlining that depending on the case. Anything you'd add to that, Eve?
Yeah, just that it depends a lot on the methodology that you're working within, and generally the methodology will lay out the process for selecting control plots. I think the stage at which Lens comes in is once those control plots have been selected and you're doing that ongoing monitoring cadence every year. So generally the way it works is you establish the control plots, you establish obviously the project site, and then either annually or every 5 years, you need to check and see what those differences are. And that's, I think, really where the efficiency gains of Lens come in, is that checking process becomes really easy.
Yeah, absolutely. Okay. Wow, there's so many good questions. Where can we find more about the details of methods regarding how you're calculating the amount of carbon sequestered? So that is something we work really closely with those data providers to make available to you as a Lens user. And that methodology and how they evaluate accuracy and all of that is going to differ provider to provider. But if you look up at one of Charles' earlier questions, I replied with an example of that documentation. And that links to their data specification and all of that. And that's something we can help break down for you as well, so that you know trade-offs or which scenarios it is suitable for and where it might not be suitable. I have one question. Does it indicate bushfires, and does it show the degradation percentage? I think if I'm interpreting that right, yes. I think the vegetation drop that Eve is showing works equally well for clearings or the loss of vegetation due to fires. You could also set up policies around specific fire layers and a percentage of the property that changes and thresholds there. Eve, anything you'd add to that one?
Yeah, we also have some fire index layers that would work in sort of a brush ecological setting that's actually picking up on the spectral signature of a burned area as opposed to that drop in vegetation. So there's a couple different ways that we can do this, but generally many of our data sets work across a lot of different types of ecosystems, and we try to prioritize adding new data sets that are as sort of widely applicable as possible.
Yeah. Does this allow for a subscriber to bring their own control point data and you interpret that? I think absolutely, if I'm interpreting that correctly. You can add, I think the cool thing about Lens is there's no limits on adding sites. So you can add as many control sites if you know them, and then add the factual. I don't know what is non-control. What's the right word for non-control?
Like the project area.
Yeah, the project areas. So absolutely, and then either through naming convention or something else, like separating them out so that they appear differently in those plots. That's absolutely something that that's exactly how Eve set up those demonstrations. And Ethan, I mentioned the Nature Conservancy of California. Ethan is the genesis of Lens. Full credit to Ethan. How about change detection for bare ground? What do you think, Eve?
Maybe to come soon.
I think we are doing a lot of experimentation that's fun. We wanted to start with these features in Lookout that were really malleable, not to just keep saying that word, but that is the theme of like giving our users full control over how they configure those to maximize understandability. Everyone has different tolerances for false positives and false negatives. And so we really wanted to give full control over that. What we're experimenting with now is a set of specialized models that can both interpret these ecological layers, but also the true color high res. I don't want to say too much, but I think we're really excited for kind of a thematic grouping of features that we're experimenting with and hopefully launching in the not too distant future. That's going to automate a ton of stuff, from potentially like picking the right image to order, the right true color high res image to order, or flagging which one seems like the best fit, to actually comparing two images and both qualitatively and potentially quantitatively describing what is contained in them. So I'm excited about that. I don't know, Ethan, if that's your exact question, but I think we're hopefully building out a set of features that builds on this Lookout piece in a way that is really exciting. Okay, I think we're coming up on time. So I think what we're going to do is we'll follow up with the recording. If you have any questions following this or want to dive into like a specific use case, Eve and I are more than happy to sit down and chat with you. That would be really fun for us, especially since this is new. And we're, as Eve said, excited to hear about the creativity that folks are going to bring to it. But with that, I think we will conclude, and we look forward to hearing from everyone. Thanks, Eve.
Thanks, Marshall. Thanks, everyone, for joining.